Okay, this video is an intro to Newton's laws, and specifically the first law of motion. By definition, Newton's first law of motion says that an object at rest stays at rest, an object in motion stays in motion unless acted on by an unbalanced. Now, unbalanced force, okay? And we'll talk more about what that means later. But it basically means if you add up all the forces, they don't cross each other out. They don't cancel each other out. All right? A quick review. This stands for sigma, okay? Which basically means that you add everything. Newton's first law actually has the sum of the forces equaling 0. Okay, so the forces are what we call balanced. The best example to show for maybe a balanced force would be, let's say you have a package sitting on the ground. It's not moving at all. Somebody comes up and pushes on one side. We'll call it force 1 with positive 50 newtons. Somebody comes up on the other side at the same exact time, and that's very important, at the same exact time, and pushes it with negative 50 newtons. What's that box going to do? Well, since it was sitting there to begin with, it's going to remain sitting there. So let's take a look at this equation, sum of the forces equals 0, and see how it applies here. It would be equal to F1 plus F2. We take that a little bit further, we get positive 50 newtons plus a negative 50 newtons. Now, some of you may be asking, well, why didn't you just take 50 minus 50? You could do that, but remember, this sigma means the addition of all the forces. Okay? That's why I like to put this addition sign here. And then if we add those up, of course, that'd be equal to 0 newtons. That is actually the very basic example for Newton's first law. To get a little more involved, we actually need to look at all the forces. Okay? That includes the sum of the forces in the x direction, the y direction, and the z direction. Now, obviously, we don't have anything coming out of the board, so the z direction is something that we pretty much ignore in here. But the y direction, there's definitely a y component to all of this. The box actually has mass and then therefore has weight. Okay? Now, I have not drawn this box falling through the earth at all, okay, falling through the ground below. So it's a pretty solid ground. If you were to take a weight and you put it on your hand, you know, you would feel weight on your hand. Your hand would also be applying a force up to counteract that. In this case, we actually call that the normal. There's no reason to really specify too much about the normal, besides it is, in this case, the amount of force that the ground is pushing on the box. Okay? So the weight is the box on the ground, the normal is the ground on the box. And if you were to look at those two things, the weight, assuming they're the same, plus the normal would also equal 0. So we actually satisfy, I guess you can say, 2 of our equations. And that's a quick introduction to Newton's first law. If you think back to what I said, that F1 and F2 were applied at the same time, I just want to make a general statement about this. Newton's first law says an object in motion will also stay in motion as long as the forces are balanced. So let's say F1 applied their force before F2. Well, that means the box would have been moving. If F2 comes up and pushes with the same force, the object continues to move just at a constant velocity. That's very important to note. Okay. I always use the example of bench pressing. Let me see if I can draw a bench here. Supports, person, pushing a bar. Pretty bad picture, but I think you understand. Let's say the bar has a weight of 200 pounds. The person has to push with a little bit over 200 pounds to get it moving. But as soon as the bar is moving up, all they have to do is apply a force of 200 pounds to actually keep it moving. So sometimes, you know, if you're ever working out, you may actually feel like, wow, I felt like I was pushing less towards the end, and that's actually probably true. Now if you fall below 200 pounds, it's going to stop, and then you're in trouble. Okay, but if it's moving up and you decrease your force down to 200 pounds, it will continue to move up at a constant speed. It might be a slow speed, but still a constant speed. So that's an example of Newton's first law of motion. Okay. And Newton's first law of motion is also referred to as the law of inertia. So basically, Newton's first law says objects like to do what they're doing. If they're moving, they like to move. If they're stopped, they like to remain sitting still. They have to be acted on by some sort of unbalanced force. Okay? We're going to get into a couple different example problems, maybe 2 or 3, involving ropes and objects hanging from a ceiling or traffic lights hanging from poles. And you actually use this sum of the forces equaling 0. You use that in solving those problems. So those will be in the next few videos.